And now, oh, even the lights went darker. Now we proceed to last but not least, very interesting, groundbreaking session about commercialization. So joining me, so you already know me, Robert. I will be. Yes. Okay, so we'll have less time than planned, but it's okay, no worries. So joining me on this panel today, we have Roger Rudolph from Atlas Data Storage. We have Vincent Cortellino from Library of Congress. We have David Turek from Catalog, and Erfan Arvani, our host by memory. Thank you very much. Thank you for joining. So, to, how to say, even the play field, what is the current situation of DNA data storage commercialization today? How do you evaluate the market? What is the situation there? Please. Anyone. Let's do this conversation type of discussion with each other, and later maybe if we have time, we will ask questions to the audience.
Is the question state of technology or size of the market?
Market. Not about technology, more about the market, the dynamics. What is the current state of the market?
I'd say that it's embryonic is a polite way of saying it. I think that when you think about DNA storage, you always have to think about it not in the context of the companies that are working with DNA, but the alternative solutions that exist in the marketplace today. Whether it's, storage companies like Seagate, Western Digital, tape companies like Quanta, on the compute side, the standard compute players, and so on. And if you look comparatively at the state of the technology, it's got a long ways to go to fit into the sort of framework that governs the way people acquire this kind of technology. So crudely, an IT director will look at a technology and they'll want it to be faster, cheaper, or better than what they currently have. They'll want it to be non-disruptive to what they currently have. They'll want it to be equipped with a roadmap that means if they adopt it, that it's got room to run and they're not going to run into a brick wall after a year or two. And they're going to want a real boost in performance to go through the effort of making a transition in technology. The standard rule of thumb on the compute side in the industry is if you bring a new technology to market, it better be 10x more than what you currently have to garner anybody's attention. And the reason for that is the effort that companies have to put into to make transition is going to consume a lot of whatever the advantages that you bring to the table. So the, crudely put, the proposition of DNA storage right now is we're not as fast, we're not as cheap, and we're hard to use. And that's a hard thing to sell, right? So you have all these ancillary benefits that people have alluded to with respect to density and longevity, energy efficiency, and things like that. But, the buyer market is pretty much driven by price performance, and these other things that I've talked about. So there's a way to go. Now, it's also the case that markets don't develop homogeneously. You start by penetrating pieces of the market and you establish footholds, you demonstrate technology and you grow from there. Emerging technology is, I'll give you a model based on my experience. When you look at introducing emerging technology into the computing marketplace, you look at 3 domains of customers that have an affinity for emerging technology. The customers have to be equipped with a lot of in-house skill to overcome any problems that your technology might provide. They have to have a mission that demands that they explore, deploy new technology, and the use cases that support it. And they have to have an urgency about what's going on, and they have to have an attitude that accepts risk, knowing that full well whatever new technology is provided might fail. The industries that typically are at the tip of the spear for that are universities, some, national laboratories. In the US, that's principally Department of Energy. Finance institutions, because they're always looking to find ways to leverage technology to money. And then you have another cadre of users who are always looking to develop some sort of strategic advantage. An example would be some of the big integrated oil companies. You think ExxonMobil, Shell, BP, Saudi Aramco, right? They have a very healthy attitude towards risk. They have a lot of in-house skill. They have the ability to accept new technologies. You wouldn't go, for example, to Pemex, a national oil company of Mexico, or Petrobras, or National Oil Company of Ecuador, or RFI, or places like that. You go to the big four and make it go that way. So to sum it up, you have to have a targeted customer base that's comfortable dealing with emerging and new technologies. They have to have the attributes that I've talked about. And you have to have a marketing plan and a message to go after those customers to get a foothold in the marketplace before you branch out to more general users.
Anything to add?
I mean, I just wanted to add that I think that data storage as a general thing has to find a use case that is not necessarily trying to compete with the existing technologies. DNA data storage isn't going to compete with tape, for example, at least anytime soon. Sequencing is never going to be that quick. Writing, access is never going to be that fast. Total cost of ownership may or may not be lower. But that's one area you can address. But I think we have to explore new types of customers and new places to use it to really find an area to grow in.
Yeah, like Roger said, I don't think, at least from the library's perspective, we're secure in the way we store stuff. So as a customer to this potential technology, we don't have problems with how we do things with our current legacy storage mechanisms. But this technology could serve a purpose to us. So I think we're potentially this niche market that Roger is speaking about, where we have items that are potentially one of a kind that we want to store forever, right? Indefinitely. And if something goes awry, we still want that item, right? So we're kind of envisioning this as we begin to delve into this realm as a seed bank type situation, where if all else goes wrong, we still have this, right? And that has its problems too, and we might get into that. But I think we are that unique customer because for all the reasons that David said, we can't step away from our current legacy technology right now because cost, it works. Yeah, we don't have any issues. We have quicker read-write speeds. We have interoperability in the market. We can buy a tape, and it's a tape, right? It's a tape for every tape drive, and we can use it. So there are some issues, but yeah, I think the library's case is one of those unique cases where we might have a reason to pursue this because we have items that we want to store, like I said, indefinitely.
Irfan?
I would say that at Biomemory, the commercial pipe is bigger than what we can manage. And if I had today the technology we promised to our clients by the end of the decade, we probably would sell every month for 50 millions. So the problem today is not the market. The market is here. They're looking for two things. The first thing is longevity, something you can't provide with microelectronics in any way. And the other thing they're looking for, to my knowledge, with my clients, big data lakes of data, I mean exabytes. Yeah, for example, I'm talking with a company developing new engines for helicopters. For those new engines, they are looking for 7 exabytes, something you can't handled properly with the kind of technology we have today. If we could deliver to them by the end of the decade those machines capable of handling 7 exabytes, yeah, they would buy it quite immediately on top of some electronical stuff. So market is here. Now the problem is to just deliver.
Okay. Vincent, you said that library is packed with old tech and you're good with it, but everyone knows that you recently announced a RFP for DNA data storage application. So why? What's happening?
A couple things. One of the reasons is what I mentioned. So we, as a government entity, first of all, we have some kind of obligation to stimulate burgeoning markets, which this is one. So we're doing that with the funding that was given to us. We're not pigeonholed into DNA data storage. That's where we started. And why is because as a government entity, first of all, we want to be on the cutting edge of what's coming out, so that's nice. But also, and I'm learning this, just a caveat, I'm new to the library. I started in January, so I've been there for a couple of months. But what I'm learning is that the people I work with have a very strong care to preserve this information for eternity, right? This is stuff that we're holding on to for both cultural and scientific purposes that we don't want to lose. So a potential advantage to DNA, for example, that people within the library are discussing is it's offline. And we were talking about this earlier. But if something were to happen, an EMP event, for example, and we were to lose everything, this is something that we envision being able to recover. Maybe the machining gets fried, right? But that can be rebuilt. The digital data potentially cannot, right? If we lose it on our current system. So that's the logic behind it. Like I said, it's not the only thing we're thinking about looking into. We're also thinking about glass and other long-term storage solutions.
Thank you. So then question for Atlas by Memory and Catalog. Are we already in a race to commercialize DNA data storage? Has the race started, or are we still picking the close to where in the marathon?
Well, I think we're in the very, very early stages of the race. There's still quite a ways to go to where we're synthesizing data in a large enough quantity for it to be really useful to a commercial customer. And there's also, and even on the synthesis side, in a sense, is perhaps closer, but on the sequencing side, or the cost of sequencing, that also has to be dropped significantly to really make it attractive for a wide range of customers. And right now, there's not a lot of drive for the existing sequencing companies that are used, whether it's NGS or nanopore-based, to drive their sequencing costs much cheaper with their own money. It's cheap enough now that for medical purposes, people are happy with it. And so to do what we need to do for data storage, there needs to be several orders of magnitude drop in cost. And there's ways to do that, I believe, but it's going to take money and effort, and we'll probably take it within our own industry or going out and getting people to do that, but spending our money one way or the other.
Well, I see Catalog, Atlas, by Memory as a team like a Dungeons & Dragons campaign, trying to not to compete but to work together. We're individuals but in the same team, and yeah, the problem is we don't have something to read because Oxford Nanopore is not something we can use. Actually, if you read the terms and conditions, you can't do that. So yeah, you all use ONT every day for research. You can't for commercially if you want to do digital. So yeah, we need another team player working on the reading part of what we develop. And if we don't do that, it'll be difficult.
And I also think some of the interoperability stuff that we were talking about earlier is important in that, if you want to be able to read that codec 50 or 100 years from now, that has to be sort of an open standard. What's done in the middle to do this, to create that stored piece of DNA can be proprietary. But I think the ability to read it back has to be universal, or it's just not going to play.
Yeah, a question we have every day from the clients is, okay, you're developing technology with DNA, DNA is sturdy, DNA will be there forever. However, how can my company can be able to read it back even in 20 years? And my clients say, oh, don't answer that DNA is a good media. Outside of the DNA, how can you read it back? And probably nobody has the answer today. So before delivering a product that can write and read every day, we should question ourselves with this difficult question, how do I read it back in the future?
Yeah, and I think that random access thing is very interesting also, because that's the other aspect. You would like to be able to store stuff in pretty large quantities, but you certainly don't want to have to sequence all of it or otherwise. So I think that's going to be kind of a critical development area as well, to really get a commercial product. And I was excited to see the number of papers that addressed that today and looked like they had a path to go down.
So there is urgency driven by another set of issues, non-competitive. The industry has suffered from the hype cycle, getting ahead of technology to a degree. So if you go back in time to, let's say, 2019, with the launch of the first MIST program, or the only MIST program, the criteria put in place for that program were to produce a device that would do 1 terabyte of data for $1, right? And everybody said, yeah, let's go, let's go. That was an insane criteria to put on the table. And in fact, when the MIST program concluded, and there were reviews of the program in Washington, it was pretty clear everybody considered it a pretty abject failure. And the problem with abject failure is it causes a government to look in a different direction, because they're going to conclude, well, it failed, so let's move on to something else. So the urgency is not competitive, is to recapture credibility with institutions that are in different governments and around the world, and also the press. You find some of the press that you approach have a little bit of fatigue, because they'll say, well, wait, I wrote about DNA storage 4 years ago, 5 years ago. So I expected it to be further along by now. What's going on? So that's what's really motivating the urgency. We have to go really fast, reestablish credibility, get back in the center of what governments are thinking about in terms of strategic investments. The competition among companies will take care of itself, and it's going to be good, because you're going to get a variety of different perspectives reflected in what the different companies do. But there is a tremendous focus on urgency right now.
Okay, thank you. Vincent, question for Library of Congress. So you're practically now investing into DNA data storage through a practical approach. What would it take? What should DNA data storage as a technology demonstrate for you to apply it further beyond the project?
Yeah, I think it's pretty clear that we're not doing a viability study with this project we just put the solicitation out for, but because we know the technology works. I mean, we talked about it for the past 2 days, right? So we know that it works. We're more so looking at the feasibility of it with our use case, right? So we're looking for that interaction between us and a strategic partner to see how it truly does work in a nascent stage with a viable user, right? So what Irvin was talking about with the end of it, right? So that's a concern of ours that is going to be part of the discussion. What happens when, yeah, we all know DNA lasts forever. That's great from a user, woohoo, right? That's great. But we can say that time and time again. We can say time and time again that you can read the DNA. DNA is DNA. I've heard that from everybody, right? You can read it no matter what. But if I was a betting person, I wouldn't bet on these 3 companies being here in 200 years, at least in the way, excuse me, in the way they exist today, right? So that's something that we want to, I guess, get to the bottom of by pushing the boundaries, right? And trying to get in here early and say, okay, well, you didn't really think about this, right? And this is what I want as a user. And to be honest, we don't know what we want fully yet. That's a problem too, right? We know what our general objectives are, which is what we put out in our solicitation. But we're going to learn what we want as the process goes on, and I think that's typical in any user in a nascent industry, right? Sometimes we have to get told what we want so that we can discover that for ourselves, right? So I think that's what we're trying to get out of it. We're trying to learn, and I think also we're trying to get the community to learn, and I think it can be construed that what we're looking for out of the project is a product, but we're looking for information. And I think that's critical in understanding, you know, the solicitation that we put out, is that, yeah, I'll end up with a thing at the end of the day, but it doesn't really mean much to the library because we're working on, you know, tens of petabyte scale. It's not something we're going to necessarily use in the future. We're looking for the reporting and the discussion and the collaboration throughout the process so we can learn from one another, right? And at the end of it all, I'm hoping that I can come back to a forum like this and discuss what the heck we learned, right? Maybe it'll be good, maybe it'll be nothing, I don't know, right? We'll have to find out, but yeah.
David, Roger, Erfan, you're talking with investors a lot, probably, or were talking before you all got money. So how do they feel? How do the investors feel about DNA data storage, about what you do, how they see the technology, how they see the risks?
Well, last round was for you. Yep. I'll talk later.
Well, I mean, there's certainly risk in there. I mean, I think we've been doing enough at Atlas to establish that the path we're going down, at least from a synthesis standpoint, as well as what we did in the past at Twist, we probably can synthesize DNA and then and store it reasonably, and then so that, you know, but it is going to take a lot of money to get to the next steps, which is why we raised quite a bit of money, because anytime you make a CMOS chip, it's an expensive proposition, and as you try to go to denser chips on smaller nodes, it's an even more expensive proposition, and you know, that's kind of why we need that level of funding, because and that's also why Twist, honestly, that's why they spun us out. Twist is, you know, a good going, viable concern. They've been in business 12, 13 years now. And they've got to the point now where they really need to become a break-even company or make a profit. And if they were to put in the money needed to do the data storage on their own, they're still a partner with us, of course. They could never, you know, essentially take forever or take another 5 years. You know, assuming we were able to commercialize it that quickly and establish customers that quickly, which I think that's what we're trying to do. Whether we can succeed at that, that'll be an interesting thing to see. But it takes a while to build a new business, build a set of customers, and really find out the business case. When we're still working on that. So, but yeah, it's we went to investors we'd worked at, not entirely, but to start with, we worked with before, and we had succeeded at Twist one time already. So that helps some in our particular case, I'd say.
Well, when we first present those type of technologies to investors, they see it at storage technology, and storage today in data centers represent nothing. So I wouldn't invest myself in storage. However, when you think about that regarding what you can do with molecules like DNA and others, other polymers, you can do compute. However, contrary to microelectronics, you need the molecules to compute. So if you can achieve a good level of storage technology with DNA, then you can compute. So you have to present to investors a road where you master storage to then go to somewhere on compute. And at BioMemory, what we want is to have this control point on storage. Then we would love to work with companies that do compute or compute ourselves. And the market is here. Investors are very happy with that kind of promise.
Not much to add. We approach the market a little differently. Our focus is on compute. You'll hear all about that tomorrow morning, so I'm not going to give tomorrow's pitch today. We made a very conscious decision of what to emphasize based on anticipated margins in the marketplace over the course of time, and decided that we'd be better served by going after a high margin business centered on compute to fund the R&D work that this whole thing is going to require over the course of time. You know, if you look at a company like Dell, which is sitting at margins that are single digit, Michael Dell has a real problem in terms of doing innovative things with this company because the margins are insufficient to really drive the investment required. We never wanted to get trapped by that. And so that's why we put a focus on compute. And that's, you know, the pitch we're making to our investors and the investor community at large, that compute is where the concentrated value is in terms of what we're doing. But you'll hear more about that tomorrow, which, by the way, is a requirement that you all come tomorrow as well. So.
Okay, and the last question for all of you. So now imagine that DNA data storage technology, computing is mature in this world now. How does the world look like?
Well, boy. So I'll tell you more tomorrow, but I think that a couple of things I'll mention. It could be quite revolutionary with respect to the amount of energy devoted to computing. You know, there are estimates that by the year 2035, all electricity is going to be dedicated to AI and to Bitcoin mining. And there needs to be a remedy for that, right? Biological computing holds a promise of having at least 5 orders of magnitude energy efficiency advantage over electronic computing, and maybe 6. So we're somewhere between 5 and 6 in our calculations. That could be a big deal. I'm going to hold the rest of my story until tomorrow.
Okay. Others?
I guess, I think the energy thing is one of the very big areas, certainly. And also the, you know, in terms of DNA itself, switching from a phosphoramidite-based chemistry to an enzymatic chemistry is also a big plus, not just for data storage, but potentially for synthetic biology as a whole. The amount of waste that's made by a company like Twist right now, it's pretty incredible. I did a study on CO2 and things like that with the various things a few years ago, and it's going to something like enzymatic is very valuable. From a standpoint of where DNA data storage fits in with the whole storage ecosystem, I'm going to just sort of see where things go and not really try and make a prediction, because I think it's still very nascent technology.
Yeah, I don't want to speak about the compute stuff that David was talking about, but storage in general, I think we obviously have a problem with storage or data production, right? And it's getting out of hand to the point where we're talking about this now. And I see it as a little bit of a double-edged sword, that if it was a viable product and it was, proliferated the industry, that we kind of take the pressure off of being responsible data producers, because now we have this, great mechanism that people will want to fill. It's kind of like when you make more money, you spend more money, right? People will live up to their income typically, and I can see that happening here. If we create the space, people are going to fill the space. So I find that to be a point of concern, and I guess, just going to sit around and watch and see what happens.
Well, in Europe, access to energy is regulated. So I see the future, it already started with smaller data centers everywhere. However, with smaller data centers, you need access to, a kind of storage and compute that you still need. So molecular technologies, molecular IT, with DNA data storage and compute with DNA or other polymers would be something you could easily fit into smaller data centers everywhere in Europe and other places where you regulate access to energy. And probably in the United States, you will also regulate energy, because if you have people that can't compete with the biggest companies to access to energy, you will have riots. So eventually you will regulate that too, and also build smaller data centers. So fit into those smaller data centers HPC of whatever, and molecules then is a proper answer on top of electronics.
And that's a wrap, guys. So thank you very much. Thank you, panelists, for participating. Thank you for listening. And the time is up.